Hi, this is Austin. Today I would like to share how to perform Boolean products similar to normal multiplication of matrices. First matrix we take row, second matrix we take column. Now let's try for the normal method to solve Boolean product. What we have to do here is first entry times with first entry. So 1 times 1 equal to 1. 0 times 1 we have 0. 1 times 0 we have 0. 1 times 1 we have 1. What we have to do next is take the union of all this. As we know, 1 union 1 equal to 1. 1 union 0 equal to 1. 0 union 1 equal to 1. 0 union 0 equal to 0. So meaning to say for this case we will obtain equal to 1. And the multiplication that we perform for the first matrix, we take the first row, and the second matrix we take the first column. So this indicates that the output 1 we should place under entry row 1 column 1. Row 1 column 1, which is this number. Okay, then after we finish the first column, we proceed to the second column. So now we have first row with second column. Perform the same multiplication. We have 1 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 1 is equal to 1. 1 times 0 is equal to 0. As long as we involve 1 in union, the answer always equal to 1. And this is first row, second column. So entry 1, 2 means that we should put it here. We perform the same procedure for all the other entries. Then we get the answer done. If we don't like to multiply one by one to obtain the answer, because it's quite wasting time, so what we have to do here, we can check the union that we obtain over here. So as we can see, as long as we have the number 1, end up the result is equal to 1. Meaning to say, 1 union with anything for sure equal to 1. Our intention is to obtain 1. So what we have to do here, we know that for the first matrix, we will definitely take row. Second matrix, we will take column. So we can cut into row and column basis. What we have to do next is, we just have to take care of the number 1. Because 0 times anything will definitely be 0. Our intention is to get the number 1. So that result will be 1. So we have, for the first row, we have first entry, third entry, and fourth entry equal to 1. So we move to the second matrix. Also, we refer to the first, third, and fourth. What happened to the second? Basically, we can ignore. So as long as when we refer to each column, we are able to obtain at least one value of 1, then the output will be equal to 1. So this is 1, this is also 1, this is also 1, and this is also 1. As we can see, we can done it quickly. So now let's move to the second row. Again, we take the number or the entry that involve only a value of 1. So it means that we just have to refer to the fourth entry now. So again, cut into column. So we have this one, ignore, 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 because what we want is just the fourth entry. Fourth entry is equal to 1. So only the first entry is equal to 1. Others will be 0. So this is much faster as compared to the normal method. Okay, we try one more row. So the third row, again, we cut into 1, 2, 3. So this one, the fourth, we ignore. We just have to refer to the first, second, and third. So ignore the last. Whenever we are able to obtain value 1, then the output must be 1. So as we can see, for all the column, we are able to get the value 1. So that's why the third row all equal to 1. Okay, that's all for today. Thanks for watching. Hope you like this. See you.